All right, here's the question. An empty can has a mass of 1/6 of a pound. This means a weight. Okay, so it weighs, an empty can weighs 1/6 of a pound. When it is filled with sand, it has a mass or a weight of 7/12 of a pound. And what we're asked to do is to find the mass or the weight of the sand in the can. I mean, you're trying to find out how much does the sand weigh by itself without the can. Okay, let's have a look then. My pencil up and running. I think the best thing to do is to draw a model. Okay, so imagine, let's have this block is going to represent the weight of the can. Okay, so this is the can, which we know is 1/6 of a pound. I'm just going to put 1/6 there. Okay, and we add to that some sand, and this is going to represent my sand. This is not drawn to scale, by the way. Okay, so this is the sand, and we don't know what that is. We don't know how much this sand weighs. Let's have a look. What do we know? We know this bit of information, and actually that's what we should have started at the beginning. What do we know? So the empty can is 1/6 of a pound, okay, and when it is filled with sand, it is 7/12 of a pound. And this is the question. Find the mass or the weight of the sand. Okay, so what's this? When the can is filled with sand, it weighs this. All right, that means that these two together weigh 7/12 of a pound. Now we could do this. We could, draw it like this. All right, this is so 7/12. Or if you can imagine, if I put another block next to it here, if I was using my Cuisenaire rods, here's another block that is the same size as these two put together, and we know that this is 7/12. Okay, now hopefully you can see that if I know what this is and I know what this one is, that if I subtract this amount from this total amount, then I will find out, I'll be able to work out how much the sand weighs. And that's what you need to do. So we need to subtract 1/6 from 7/12. And here is where the challenge of the problem is. Let's have a look. So we've got 7/12, subtract 1/6. And as I said, this is the challenging bit, because if you notice, the denominators are not the same, and we cannot add or subtract fractions unless the denominators are the same. So what we first need to do is to convert these fractions, one or both of them, to equivalent fractions of the same value which share the same denominator, that have the same denominator. Now in this one I really only need to change this 1/6, because I can very easily convert that into 12. So I'll do this over here. Okay, so 1/6, I want to convert it into 12ths. All right, that's the denominator that I want. What do I have to multiply 6 by to get 12? Well, yes, that is 2. 6 multiplied by 2 equals 12. Now, if I'm to maintain the same value and to make sure that this fraction is equivalent in value to this one, I have to multiply the numerator, the top number, by the same amount. So I have to multiply that by 2, I get 2. So 1/6 is equivalent to 2/12. So I can rewrite this as 7/12 subtract 2/12. And what does that equal? Well, now that my denominators are the same, I can do a very simple subtraction now. 7 take away 2 is 5. All right, if I had 7/12 and I took 2/12 away, I would be left with 5/12. And that is my final answer. All right, so the sand is 5/12 of a pound. All right, it's always useful to label your answers so that you know which one of your calculations, what they all mean. All right. The other thing we need to check is, can we simplify this anymore? No, we can't. Okay. Is there a number that would divide evenly into both top and bottom? No, there isn't. So 5/12 of a pound is the final answer.